Hi, hello, how are you? This is your Gopal. Welcome to Physics Rank Guru. All of you, wish you a very happy new year. Okay, today we are going to discuss rotatory motion, lecture number 10. In lecture number 10, we can discuss torque or momentum of force or turning effect of force. In this lecture, we can discuss torque, momentum of force or turning effect of force. First of all, what is translatory motion? In translatory motion, translatory motion and rotatory motion. In translatory motion, linear displacement is S, and angular displacement is theta. In rotatory motion, angular displacement is theta. So here linear velocity is v. In translatory motion, linear velocity is v. In rotatory motion, angular velocity is omega. Okay. Next one, in translatory motion, linear acceleration is a. In rotatory motion, angular acceleration is alpha. Similarly, in translatory motion, linear force is F. So in angular motion or in rotatory motion, force act as like a tau. So here tau is called what? Torque or moment of force or turning effect of force. Okay now. So torque is analog to. So in rotational analog of force is torque. Okay. So we can discuss today about torque. So I will consider a nut, bolt or nut. This nut is rotated with a spanner. This is the spanner. This is arm length of spanner, arm length. So in case this is arm length is, I will consider R, and applied force is like that F. Okay. In case I will consider the same nut, same bolt. This is a fixed. Bolt is fixed. I will consider spanner of length is double. Spanner of a length is double. Arm length is double. This becomes is 2R. So here turning effect is reduced to half. So there is a turning effect in both the cases. So here turning effect is reduced to half. Length is increased means turning effect is reduced. In case length is increases, turning effect is reduced. Suppose you can apply the force. Applied force is like that, parallel to the arm length. There is no turning effect. The applied force is parallel to the arm length. There is no turning effect. So here in this case, applied force is parallel to arm length. There is no turning effect. Applied force is parallel to the arm length. There is no turning effect. In case applied force makes some angle with the arm length. So this is the applied force acting like that, F. So this is the reference line. This is the axis of rotation. These are reference lines. So this is the arm length. Arm length is R. So makes an angle theta with the arm length. Okay now. So this F is all into two components. Along the theta is F cos theta, and other than theta is F sin theta. So here F cos theta is parallel to the arm length. So here F cos theta is parallel to arm length. So there is no turning effect. Now only we discuss. There is no turning effect. There is no turning effect. In case that f cos theta, f sin theta F sin theta is perpendicular to arm length. So there is a turning effect. There is a turning effect. There is a turning effect. Turning effect. So turning effect you can write here. Turning effect turning effect of force you can represent like a torque symbol is what? Torque, tau. Tau is equal to here R into force perpendicular. R into force perpendicular. So what is the R? So this is the arm length. What is perpendicular force is what? Here F cos theta. Means you can write torque is equal to RF sin theta. RF sin theta. Otherwise you can write here torque tau is equal to R perpendicular into F, or R into F perpendicular, or R perpendicular into F, right? Your torque is equal to RF sin theta. In case write in vector form, so torque is equal to R into F perpendicular. So here F perpendicular means component of a force F sin theta, component of a force F sin theta alone participate turning effect. Alone participate turning effect. So here you can write vector form of torque. Vector form of torque R tau bar is equal to R bar cross F bar. R bar cross F bar. Remove the cross product, you can write RF sin theta. RF sin theta into n cap. Into n cap. Torque tau is equal to RF sin theta into n cap. So here n cap is a unit vector. N cap is a unit vector that is perpendicular to R into F. N cap is a unit vector that is perpendicular to R and F. So what is the angle theta here? The theta angle between that theta is angle between force and R and F. Theta is angle between R and F, right? So this is about torque. Tau is equal to R F perpendicular, or otherwise R perpendicular into F. You can write this one. Torque tau is equal to R F sin theta. R F sin theta means component of a force. Torque tau is equal to R F sin theta. So what is unit of torque? What is SI unit of torque is Newton meter. Newton meter. SI unit of torque is what? Newton meter. CGS unit is dyne centimeter. CGS unit is dyne centimeters. So it is a vector physical quantity. It is a vector physical quantity. It is a vector physical quantity. And dimensional formula is dimensional formula m L square t to the power of minus 2. M L square t to the power of minus 2. And here direction can be determined. Here direction of torque can be determined. Direction of torque can be determined by using right hand thumb rule. Right hand thumb rule. Right hand thumb rule. Direction of torque can be determined by using right hand thumb rule. So torque tau is equal to R into F perpendicular. Here F perpendicular means what? F cos theta, F sin theta. So tau is equal to R F sin theta. So SI unit is Newton meter, CGS unit is dyne centimeter. Vector is a vector physical quantity. Its dimension formula is m L square to the power of minus 2. M L square to the power of minus 2. So we can determine the by using direction. Direction can be determined by using right hand thumb rule. For example, I will consider. So this is the axis of rotation. This is the axis of rotation. So from the axis of rotation to some r distance, so force is applied like that. Force is applied. So this is component of a force like that. You can extend. This is component. This is r line of action of r. This is a line of action of r. You can consider the line of action of force is this is. So what I said. So r perpendicular. R perpendicular means this is angle theta. Angle between r and f. So this also angle theta. So you can write r perpendicular is, you can draw here. So this is r perpendicular. So you can write r perpendicular is equal to sin theta, r sin theta. R sin theta. Okay. So what about this one? So this is r cos theta. So what is torque? Torque tau is equal to R perpendicular into force. R perpendicular into force. So in this case, by using right hand thumb rule, so along the R you can place the right hand fingers like that and curl towards F. So here means here torque is out of the plane. Torque is out of the plane. So in case torque is out of the plane, you can consider or torque is out of the plane, means out of the plane. Torque is out of the plane means what? Anti-clockwise sense. We can consider torque is positive. So in case torque is into the plane, torque is into the plane means clockwise sense. You can write you can consider torque is negative. So see some examples. So based on torque we can see some problems. So example 1. So I will consider a disc of a radius is R is equal to 2 meters. So in case this applied force is like that, F, applied force F is equal to 10 newtons. You can find out the here torque. Turning effect you can find out. Okay. So here what is the torque formula? Torque tau is equal to RF sin theta. So what is the angle here? So this is radius vector. This is what? Force vector. So force vector is this one and radius vector is this one. This is R and this is what? Force. Angle between these two is 90. So what is angle between force radius vector and force? So is 90. So theta is equal to 90. So torque tau is equal to, what about R? R is equal to 2 meters. And force is equal to 10 newtons. R is equal to 2 here. 2 into force is equal to 10 newtons. 10 into sin 90. Sin 90 value is how much? 1. You can write torque tau is equal to 20 Newton meter. Torque is equal to 20 Newton meters. So you can find out the direction. The direction is clockwise sense or anti-clockwise sense. Along the R you can place the finger and turn towards the force. Means so there is no chance here. So you can, this is the radius vector and you can turn the fingers towards the force. Means thumb is into the plane. Thumb is into the plane means you can write the clockwise sense. So CW. So 20 Newton meters clockwise. Direction is clockwise. Next problem we can discuss. So bolt or nut is fixed. So this is fixed and you can spanner of length is 1 meter. Spanner of length is 1 meter. Spanner of length is 1 meter. So means this is here to here. So here applied force is F, makes an angle 37 with the radius vector. This is the radius vector. So this is here to here. Okay na? Arm length. So this is the arm length. Extend arm length. So mean this is R. So this is F. So this is 37 degrees. So means here this F is into two components. So here F is equal to 10 newtons. That makes an angle 37 degrees with the arm length. So right. So this F is into two components. So this is F means this is 10 sin 37. This component is what? 10 sin 37. And this component is what? 10 cos 37. So this, by using 10 cos 37 there is no turning effect. So your turning effect is equal to 0. So turning effect is F perpendicular. So we know formula torque is equal to R F perpendicular So RF sin theta, RF sin theta. What about here R is equal to 1 meter, and what about F? 10 into sin 37, sin 37. So using this sin 37, so this is right angle triangle. In case this angle is 37, this opposite side you can write 3, and adjacent side you can consider 4. Okay, so this is what hypotenuse is, what 5. So sin 37 is equal to 3 by 5. Here cos 37 is equal to 4 by 5. So that 3 is exactly opposite side you can write, and 4 is adjacent side you can write. So sin 37 is equal to 3 by 5, and cos 37 is equal to 4 by 5. So you can write here 1 into 10, I mean this is 10, sin 37 is 3 by 5, 2 ones, 2, 5 ones, 5 twos, 2, 3, 6 Newton meter. 6 torque tau is equal to 6 Newton meter, right? So that is, you can find out the direction here. So this is arm length, angle between you can consider angle, so where two initial point, otherwise two terminal point. So here this is arm length, this is R, initial point is this one, and force initial point is this one. This is angle is 37. Now you can consider right hand rule. Along the place the fingers along the R and curl towards the force, and here direction is out of the plane. Out of the plane means here anti-clockwise sense. Into anti-clockwise sense means out of the plane means torque tau is equal to 6 Newton meter anti-clockwise. 6 Newton meter anti-clockwise. Understood, all of you? So can I discuss one more example? I will consider example. So this is a simple pendulum of a mass is 1 kg. And this length is 1 meter. This is 1 meter. So makes an angle theta. So this simple pendulum makes an angle theta. You can find out the turning effect here. So this is 1 kg. So here this weight is acting downwards, mg is acting downwards, and you can extend this, okay, na, R. So this is R. This is 30 means this is also 30. So what is torque? Torque tau is equal to RF sin theta. Torque tau is equal to RF sin theta. So what about here R? R is equal to what? 1 meter. 1 into what about force? Force 1 kg means 1 into acceleration due to gravity is 10 sin 30. Sin 30 value is 1 by 2. So 10 into 1 by 2, 2 ones, 2 5s. So 5 Newton meter. So torque tau is equal to 5 Newton meters. So clockwise sense or anti-clockwise sense by using right hand rule, okay na? Along the R fingers and curl towards force mg, okay na? Means that is what clockwise sense. So 5 Newton meter clockwise. 5 Newton meters clockwise. I will consider one more example. Disc of a radius is, I will consider a disc. So disc of a radius is 2 meters. Disc of a radius is 2 meters. So here tangential force is acting 20 newtons like that, and one more tangent force acts like that. So this is tangential force acts like that, 20 newtons, and one more tangential force act downwards here 10 newtons. Radius of vector is 2 meters. Here find out the torque. So this rotating like that in clockwise sense, you can find out turning effect torque you can find out. So you can consider 20 newtons here, find out the torque, and 10 newtons you can find out the torque, and net torque you can find out, you will get the answer, right? So torque tau with respect to force 20 newtons, So RF sin theta, RF sin theta. You can find out the angle between radius vector and force vector. So this is a radius vector. Extend this radius vector. This is R, and this is what force. Angle between is 90. So here theta is force and R, F and R is 90 degrees. So torque tau is equal to radius vector is 2 meters, 2, and the force vector is here 20 newtons into sine 90. Sine 90 value is 1. Sine 90 value is 1. So torque tau is equal to here 40 newtons meter. 40 Newton meters. Clockwise sense or anti-clockwise sense. So along the radius vector you can place the fingers and curl towards the force. So this is clockwise sense. Clockwise sense I will consider CW, clockwise sense. So what about 10 Newton force? So here this is here also, this is also radius, this is 2 meter means this is also 2 meters only. Okay, this is what radius vector. Angle between this radius vector and the force is 90 degrees. We also can find, I will consider this is torque T1 and torque T2 is equal to, so same RF sin theta. So R is 2 meters, here force is 10 newtons into sin 90 value is 1. When this is 20 newtons. 20 newtons. You can find out the direction here. Along the force, along the radius vector, you can place the fingers and curl towards the force. So this is anti-clockwise sense, CACW. So you can find out the net torque. Net torque is equal to T1 torque tau 1 plus tau 2. Tau 1 plus tau 2. So here there is a CW. Clockwise sense means you can consider negative. Anti-clockwise sense means you can consider positive. Okay, now you can consider positive. Means that T1 is equal to here minus 40 Newton meters and T2 is equal to plus 20. So answer is here minus 20 Newton meter. So this is a net torque. So net torque is equal to minus 20 Newton meters. Otherwise you can write the net torque is equal to 20 Newton meters clockwise sense. 20 meters clockwise. Clockwise means here you will get negative. Okay, na? Remove the clockwise sense, you will get minus. So you can write clockwise sense. So no need to write minus. Okay, na? Net torque is equal to 20 Newton meter clockwise sense. So understood all of you? Okay. You can discuss one more example. So if force vector is 2i cap minus 3j cap and radius vector is 3i cap plus 2j cap, then find torque. So we know torque tau is equal to, in vector form you can write r bar cross f bar. So cross product of two vectors by using, you can write a matrix determinant method. So you can write first I, J, K. So first you can write R, I magnitude is 3 and J is 2 and K 0. So first then you can write F. So here 2, here minus 3 and here 0. Okay, now you can find out. So first you can write I and I columns and I rows you can cover and remaining you can cross multiplication. So here 2 into 0 and 3 into 0, this total term is 0 and minus J. So here J terms and J rows and J columns, other columns you can cross multiplication. So 3 into 0 or 2 into 0, these two both are 0 only. So plus K. So here K rows and K columns, except K rows and K columns, remaining can multiply. 3 ja minus 9. So here minus 2 2 ja 4. So you can write minus 13 K cap. So here minus 13 K cap, like that you can do. So torque tau is equal to minus 13 K cap. Minus 13 K cap means along the negative Z axis. Understood? So next example. So a force F is equal to 2I cap minus 2J cap minus K cap is acting at a point 1 comma 2 comma 3 and find the moment of force about the point 0 comma 1 comma 3. So means about this point you can find out, so force, torque you can find out, momentum of force. So means here initial point is 0 comma 1 comma 3. So this is initial point and final point is, okay, 1 comma 2 comma 3. About this point you can find out that momentum of force. Moment of force. About this point you can find out moment of force. So moment of force torque tau is equal to RF sin R bar cross F bar. So here F bar is there, but you can find out R bar. So here R bar is equal to, so final point minus initial point. So means RP bar minus R initial point RO bar. So this is the initial point, this is final point. Means RF minus RI. So you can write RF means I cap plus 2J cap plus 3K cap minus RI means 0 I cap plus J cap plus 3K cap plus 3K cap. Means subtract this one. So R bar is equal to I cap 2J minus J plus J cap 3K minus 3K. So this is a 3K and a 3K. This is point I will consider 2. So this is 2J 2K cap 2K cap. So means 2K minus 3K minus K cap So now you can find out, means here R bar is equal to I cap plus J cap minus K cap and force F is equal to 2I cap plus 3J cap minus K cap. You can find out by using vector determinant method, you can find out the torque. Okay. Now torque tau is equal to R bar cross F bar is equal to, first I can write I, J and K. So R I component I magnitude is 1 and J is 1, this is minus 1. So here 2, 3 minus 1. First you can write I, torque tau is equal to I minus 1 and minus, here minus is there, minus of minus plus, so plus 3. So minus J of minus 1 and plus 2 plus K cap 3 minus 2. So can torque tau is equal to 2I cap plus 1 minus J cap plus K cap. So this is the torque tau bar. So what is, you can find the momentum of force, you can find out the magnitude. Torque tau, magnitude of torque is equal to 2 square plus 1 square plus 1 square under root. You can find out the magnitude. So 2 square 4 plus 1 plus 1. So means root 6 Newton meter. All of you happy new year once again. So regularly watch my videos, like, subscribe and share my videos. So all of you bye, take care, have a nice day. Today class you can complete and you can meet next lecture. Okay, all of you bye, take care, have a nice day.